Hey, welcome guys. Welcome back to my YouTube channel. In my previous video, I showed you how to solve partial fractions or partial fraction expansion, whatever I call it. So you can do it. Check it out. This one will be showing how to show partial fractions with repeated denominator. What I mean by the repeated is that you have a square on it. You have a square on it. In the previous one, so there was no square on any of our denominator. So this one we're going to be looking at expansion of it. The idea is you saw how we split it in our previous video. This can come from maybe after getting this could have come from maybe like this, so x plus 5 all over that's if you open these fractions. Maybe this was the initial question and you got this, or you just have this. The initial question could have been this. Then factorize this too. I've done videos concerning that. Just check it out, and I'll leave a link above so you can check it out. So if you have this, I want to do the partial fractions. Now previous video we did something like this. So what we just did was could have just done let's say that's how it will now be a 1 plus minus 1. This based on our previous expression, this might what come to mind first, but this we can't use this approach towards it because the idea is partial fraction is splitting this to a sum of this. That is, if you add it back, you should have you should get this. So instead of using this, why this can be quite okay to get this, but this other part of it now, you have to, instead of this, you replace it with this. Because the idea is just that if you eventually add this, you have something like this minus square. That'll be a plus b. But in inside of this, you just the denominator will just still be x minus 1. I hope you get what I'm trying to say. So now to solve this now, write okay. Let me just so write this as so x equals to a, like we said, plus b, like we said, minus 1 square, then plus c that we didn't touch earlier. So now to do this, like we did in our previous video, we multiply the denominator by the general the whole term by the denominator. Like this will multiply this will multiply this will multiply this will multiply this. So multiply true. So when you multiply this all true, so when you multiply this true, you have 2x plus 5, right? If you multiply this through with this will cancel one of this, so you have it will still remain 1, so that'll be x1. Then this will totally cancel this o1, so that'll be b will remain x minus 2. And this last one, that is c over x minus 2. That will be reduced. To this will cancel out this, so you have c x minus 2. So sorry, minus 1 all squared. So now we have this. Now previously what we did was that we look for what you could like put into an x that we use to eliminate the other ones, like the other unknowns. Our unknowns are a, b, c, right here. We're trying to look for a, b, c. So if, for example, if we the idea is just to make 1 completely 0. When we make this 2, that is 2 minus 2 give us 0. When we make x2, this will automatically go to 0. Then 2 minus 2 also give us 0. So this and this will get eliminated. So what is let's just say where x is 2. The idea is just to look at what to be what to add or subtract to the factor with a term. So 2. So yeah, so substitute 2 or 2 to wherever you find x, and 2 plus 5. So 2 minus 2 will give us 0, and 0 times this, whatever it is, we still give us 0 times will give us 0. Then 2 minus 2 will give us 0, so 0 plus 0, but usually this down give us 0. So we see x, so sorry, x is 2 minus 1 square. So 4, 2 times 2, 4, 4 plus 5, 9. That will give us, we already have this, should give us 1 square. So that will c is equals to, so c is equals to 9. Then to find our second term now, then you can make is 1, sorry, so we'll make c 0. When we make c 0, we just make x equals to 1. When and x equals to 1, that's because this also turns to 1, then n is to get eliminated. So when x equals to 1, you have 2, 1 plus 5 equals to, this is 1 minus 1 give us 0. Multiply this, multiply it, give us to 0. B x, that'll be 1 minus 2 plus 1 minus 1, 0, 0 square, 0. So this will give us 2 plus 5, that will be 7 all over b open bracket minus 1, right? So just take this up, so continue from there. Then we have 7 equals to minus b. Oh, I'm looking for b, I'm looking for minus b, I'm looking for b. So that divided by minus 1, we have equals to minus 7. So to get our last term from this now, there's nothing we can put to these two to get us any of those factors. What we can do is just that we make x 0. When we have x 0, when we make x 0, this will remain, this will also remain, this will also remain. What we'll do is that since we already have b and c, just eliminate it, input it into the equation. So let's just bring this here, so you see what I'm doing. So 2x plus 5, right? 2x plus 5. Then when x equals to 0, so 2x plus 5, that will give us 0 plus 5. When you have 0 here, is equals to, that will give us minus 1, minus 2. This will give us plus, we already know what b is. B is minus 7. And minus 7, x plus 2, no, x minus 2. That will give us, since our 0 is, so we have minus 2. So I'm multiplying this together, then plus c. What's our c? You have c to be 9. C to be 9. Multiply by 0 minus 1 squared. So we are having something like, this will be 5, since this will give us 0. That will give us a minus 1 minus 2, that will give us 2a. All they are still together. Then plus, I'm not saying, sorry about that. Okay. Yeah, so this will be 5, this will be minus 2, this time this minus 2. Sorry, 2a, 2 times a, 2a. Then this will give us plus 14. Then this, we have minus 1 square, give us 1 times minus 1 gives us plus 9, 1. So you have this, right? So you can just do our maths. Let's take this other two to the side. 5 minus 14 minus 9. If you put this into your calculator, you should have minus 18, right? I'm not wrong. It's 5 minus 1, that is that's 4. That's 4 here. So a is then equals to minus 18 over 2, that gives us minus 9. So we have to input this back into our first equation. This first equation here. From our first equation, we have, let's first get what our a is. Our a is minus 9. B is B is minus 7. Now C is, just trying to show yourself, won't make any mistake. 9. So from our previous equation, we have this, so to be 2x plus 5 over x minus 1 square, x minus 2 plus 2, a plus b plus c. So what's that? A is minus 9 plus b plus c. Can leave the bracket, can I write this proper to b? So I have to be. Instead of doing like this, can I write it like a plus 5? Yeah, you can just make this first. X minus 2, then minus 9, 1, then minus 7. So just to make it look cool. Can you see? Sorry. Just writing this again. Just bring this here. Then make this here. So the minus will be minus be here. So this will be not be here. So that's all for this video. In the next video, I'll be showing you how to solve this in another method. This instance, in this situation whereby we might not be using, when we get to, sorry, I'm just trying to figure it out. Yeah, when we get to this point, can use another method instead of using the elimination method. I'll just we'll expand this out, then we'll just turn it to a simultaneous equation. That will be more cool. So let's see, we'll see in this next video. Just like and subscribe. Thank you.